So here we're looking at finding the average value of a function. So you want to begin by noting that we can use the midpoint rule and the area approximation to find the average value of a function f over an interval. So we define this as f with this little bar on the top to indicate the average value, and this is going to be equal to the area under the curve by the midpoint rule. And this is all divided by the length of the interval. So that's the difference of those endpoints. So let's go ahead and take a peek at some examples. Use finite sums to estimate the average value of f over the given interval by partitioning the interval into 4 subintervals of equal length and evaluating at the subintervals midpoints. And here we are given the reciprocal function 1 by x over the closed interval where x is greater than or equal to 1, less than or equal to 9. So here we're asked to use 4 subintervals. So we're going to let n be equal to 4 subintervals or 4 rectangles. And our closed interval is given. We have x naught to x sub n, or a to b, being defined as 1 to 9. So we want to find the width of each subinterval that we're going to use. So our width is delta x, and this is equal to the length of the interval, x sub n minus x naught, all over the number of rectangles. So we have 9 minus 1, all divided by 4. So we have 8 over 4, which leaves us with 2. So therefore, the width that we'll be using here for the subintervals is 2 units long. So let's go ahead and find our subintervals now. So again, keep in mind with the subintervals that we're taking our given interval and we're going to divide this up into 4 parts, each 2 units long. So starting with the first endpoint, we have 1, and we think to ourselves, okay, 1 plus 2 gives us 3. So there's our first subinterval. The next interval, or the next subinterval, starts at the previous interval's endpoint, and we again think to ourselves, okay, 3 plus 2 is 5. So there's our second subinterval. Our third subinterval, we use the previous interval's endpoints. We have 5, and we think to ourselves, okay, 5 plus 2 is 7. And last but not least, we have the interval 7, and 7 plus 2 gives us 9, which again is a great checking point. This last endpoint should match the right-hand endpoint of your given interval, and so we're good. Now here, we note that we want to use the midpoint of each one of these subintervals. So let's quickly, we can even see them here. We have nice whole numbers, so we can see that the midpoint of this subinterval, say m sub 1, is 2. The midpoint of our second subinterval is going to be 4. The third midpoint of our third subinterval is going to be m sub 3, which is 6. And last but not least, the fourth midpoint of our fourth subinterval is 8. So these are the midpoints that we're going to use to calculate the height. So let's go ahead now and sketch a graph, and we'll calculate the heights for each midpoint. So here we go. We've got our y-axis and the x-axis. And we'll keep in mind here, we're just thinking about the portion of the reciprocal function between the endpoints 1 and 9. So we're just thinking about, say here is the portion of our reciprocal function that we're thinking about between our endpoints. And we want to find the area under this curve. So that's 1 by x, such that x is greater than or equal to 1, less than or equal to 9, and we need to incorporate our other endpoints here. So there's 3, 5, and 7. And so we want to use the midpoint of each one of these subintervals here to find the area. So let's actually, we'll shade our bounded region here so we know what exactly we're looking for. We're looking for the area under the reciprocal function above the x-axis between x is 1 and x is 9. So the midpoint here at 2. So we can go up, march up to our function. And so this point is what's creating that rectangle. So here is your first rectangle. The second midpoint is at 4. And we march up to that function, and so we can use that point to create that second rectangle. And we can even label these points. That's f of 2. That's going to be the height we use. Here's f of 4. Again, the height that we're going to use. Our third midpoint's at 6. Marching up to the function. There's that third rectangle at f of 6. And then last but not least, we have our fourth midpoint at 8. And we use that midpoint to create the rectangle. So we are ready now to go ahead and find the heights and approximate our area. So the heights, again, we're using the midpoints. So in our first interval, 1 to 3, we want to calculate the height at 2. So this gives us 1/2. In our second subinterval from 3 to 5, we want the height at the midpoint, which is 4. So we have 1/4. Our third subinterval, 5 to 7, and we want the height at the midpoint, so that's f of 6. We have 1/6. And last but not least, our fourth subinterval is from 7 to 9, and we're calculating the height at the midpoint, which is x is 8. And plugging that into the reciprocal, we have 1/8. So we can approximate the area. And we, of course, recall that area is approximately equal to the width multiplied by the sum of all those heights that we just calculated. So our area is approximately equal to, we have a width of 2 multiplied by the sum of these heights, evaluated at our midpoints. So I have 1/2, 1/4, plus 1/6, plus 1/8. And so to combine up all these fractions here, we need a least common denominator, which is going to be 24. Right, so we can think about multiplying the top and bottom of 1/2 by 12, the top and bottom of 1/4 by 6, top and bottom, or numerator and denominator of 1/6 by 4, and last but not least, we'll multiply the numerator and denominator of 1/8 by 3. And so this gives us that we have that this is approximately equal to 2 multiplied by 12 plus 6 plus 4 plus 3, all divided by 24, our least common denominator. 2 goes into 24, thank goodness, 12 times. And so we have that the area is approximately equal to 12 plus 6 is 18, plus 7 gives us 25/12 square units, because that's our area approximation. So there's your area by the midpoint. The only thing here is don't get so excited that you found the approximate for the area that you forget what we're trying to do here. We want to find the function's average value. So we're looking for the average value of f. So that's going to be f bar, and it's equal to the area, or we should say the approximate area by the midpoint, which we just found above, and that's all divided by the length of the interval. So the difference between your endpoints. So we found the approximation for the area to be 25/12. And now we want to divide this by the length of the interval, which is 9 minus 1. So we have 25/12 divided by 8. And again, if we think about this 8 in the denominator as being a fraction, or 8/1, we can simplify. This is 25/12 multiplied by 1/8, which leaves us with that beautiful final answer of 25/96. And so this is our final answer here for the average value of our function f over the interval 1 to 9.